Throughout history, few pieces of technology have defined human warfare like armor. In the Middle Ages, knights wore full suits of steel that could turn deadly blows into harmless glances, allowing them to survive brutal battles that pushed both human endurance and engineering to the limit. Today, soldiers rely on body armor built from advanced fibers and ceramics. Yet many of the core ideas behind modern protection were perfected centuries ago. Medieval armor wasn't just metal. It was science, strategy, and craftsmanship combined into one system of survival. Its design principles, deflection, balance, and adaptability remain so effective that even with all our technology, modern armor still struggles to achieve the same harmony of protection and mobility that knights once carried into battle. Number 1. The power behind the steel. Medieval armor was a masterpiece of practical engineering that combined strength, balance, and flexibility in ways that still impress modern scientists. Despite its metal construction, it wasn't as heavy or restrictive as people imagine. A full suit of plate armor usually weighed around 20 to 27 kilograms, comparable to the total load carried by today's soldiers with their modern gear. The key difference was how the weight was distributed. Armorers shaped each piece to match the body's natural movement, spreading the weight evenly from shoulders to hips. This allowed knights to walk, run, and even mount horses with surprising agility. The secret behind its effectiveness was deflection. Every curve and ridge of the steel plates was carefully designed to redirect the force of a blow, instead of absorbing it directly. Swords, arrows, and even early firearm projectiles often glanced off instead of penetrating. This concept deflecting energy, rather than stopping it head-on, is the same principle used in modern vehicle armor and ballistic protection. The overlapping design of the plates provided continuous coverage without major gaps, while the joints allowed for full body motion. Crafted from hardened steel, this armor could resist incredible impact. Historical tests and modern reconstructions show that high-quality plate armor could stop arrows, sword strikes, and crossbow bolts with minimal damage. When combined with padded undergarments and chainmail, it offered layered protection that distributed shock across the body. Knights wearing it were not slow-moving tanks, but highly mobile warriors, protected by one of the most advanced personal defense systems ever created. In essence, the genius of medieval armor lay in its balance of strength and mobility. It didn't just protect, it enhanced confidence and endurance on the battlefield, proving that centuries-old craftsmanship can still rival the technology of modern body armor today. Number 2. Built to face real combat. Medieval armor wasn't made for comfort or display. It was engineered for survival in the chaos of real warfare. Unlike modern body armor, which is designed mainly to stop bullets and small fragments, medieval armor had to endure a brutal variety of threats. Knights faced swords, axes, spears, maces, arrows, and even early firearms, often all in a single battle. That meant their protection needed to handle slashing, stabbing, and crushing impacts from every direction. Armorers of the time were true engineers, experimenting constantly with materials, angles, and layering to protect soldiers from the unpredictable. Each layer served a distinct purpose. Beneath the metal plates, there was a padded garment known as a gambeson, made from tightly quilted linen or wool. This layer absorbed shock and prevented bruising from blunt strikes. Over that came chainmail, offering flexibility and resistance against cutting and piercing attacks. Finally, the outer layer of hardened steel plates deflected direct hits. Together, this combination created a dynamic, multi-layered defense system that could stop a sword swing, dull the blow of a mace, or make an arrow glance away harmlessly. Modern Kevlar vests, while excellent at absorbing the energy of bullets, are highly specialized. They struggle against knives, spikes, or heavy blunt force trauma. That's why riot police and bomb disposal units often wear rigid plate armor similar to medieval designs, because layered rigidity and deflection are still the most reliable methods of protection against mixed threats. Medieval armor was also built to be modular. Knights could remove or add pieces depending on the battle situation. Full plate for open combat, lighter protection for mounted patrols or sieges. The craftsmanship behind it went beyond simple metalwork. Smiths carefully studied how blows landed, shaping each plate to guide strikes away from vulnerable joints and arteries. Even the smallest curve or ridge on a breastplate had a function: it redirected energy and reduced the chance of penetration. This focus on real-world combat performance made medieval armor uniquely versatile. While modern soldiers rely on external gear and technology for added defense, knights carried their entire protective system on their bodies. What makes medieval armor remarkable is that it solved problems that modern body armor is still trying to overcome, balancing mobility, durability, and all-around protection. It was a complete adaptive shield for the chaos of battle, built to face not just one weapon, but the entire arsenal of war. Number 3. The physics of survival. Medieval armor wasn't just a product of brute metalwork. It was a masterpiece of physics applied centuries before anyone formally studied impact dynamics. The core idea behind its design was simple yet brilliant: redirect the force instead of absorbing it. Every curve, angle, and ridge on a knight's breastplate or helmet had a purpose. When a sword, spear, or arrow struck, the rounded steel didn't take the full hit directly. It guided the energy away from the body. This principle of deflection remains a foundation of modern protective engineering, from tank armor to combat vehicles. Unlike today's soft ballistic vests that depend on absorption, medieval plate armor relied on the manipulation of motion and momentum. When force met the angled surface, kinetic energy spread over a wider area, drastically reducing the point of impact. That's why a well-crafted breastplate could survive multiple hits from swords or arrows without deforming. The steel's elasticity and shape worked together, transferring energy throughout the armor rather than letting it concentrate on one spot. This concept, controlling how energy flows across a surface, is identical to how modern aerospace engineers design jet fuselages or car crumple zones. The layering also played a vital role in survival. Beneath the steel, knights wore a padded gambeson, which acted as a primitive shock absorber. The quilted fabric compressed under pressure, converting some of the kinetic energy into heat and motion. It prevented broken bones and internal injuries from blunt strikes. This was centuries before humans even had scientific language for kinetic transfer or energy dissipation. Yet blacksmiths intuitively perfected it through experience and experimentation. Another overlooked advantage was the material itself. Medieval armor was often made from tempered steel, a heat-treated alloy capable of balancing hardness with flexibility. If the metal were too hard, it would shatter like glass. Too soft, and it would bend. Armorers found a precise middle ground, much like how modern engineers harden ballistic plates with ceramic composites. The result was metal that could absorb vibrations without breaking, preserving structural integrity even after repeated impacts. In essence, medieval armor was physics in motion, a moving system that used energy against itself. While modern body armor focuses on stopping a single type of projectile, knights depended on a design that countered everything through clever geometry, layering, and controlled energy distribution. It wasn't just protection, it was centuries of battlefield-tested physics refined into steel. Number 4. The human element. The true strength of medieval armor wasn't just in its metal, it was in the people who wore it. Knights weren't ordinary soldiers handed standard equipment. Every suit of armor was handcrafted to fit its owner's exact body shape, down to the curve of the shoulders and the length of the limbs. This level of customization made it function almost like a second skin, allowing the knight to move naturally, swing weapons, and even run or ride for hours. Unlike modern soldiers, who receive mass-produced armor that must fit a general size, medieval warriors had armor built specifically for them, ensuring perfect balance and comfort during long campaigns. Training was another key factor. Knights spent years mastering combat while wearing armor, so their bodies adapted to its weight and rhythm. The armor became an extension of their movement, not a burden. Contemporary reports describe knights performing rolls, jumps, and fast strikes with surprising fluidity. They didn't need to get used to their armor. It was part of their identity. This level of integration is something modern warfare rarely achieves because today's body armor, though protective, isn't designed to merge with the soldier's form. It's a piece of equipment, not an extension of the fighter. The psychological connection was equally powerful. A knight's armor symbolized honor, lineage, and courage. Losing it meant losing status, and protecting it was a matter of pride. That emotional link built confidence in battle. Knowing that their armor could withstand arrows or blades allowed knights to charge fearlessly into close combat. This psychological edge trusting your protection completely gave them strength that statistics alone can't measure. Modern soldiers, in contrast, often rely on external gear and technology rather than personal craftsmanship. Their armor protects them physically, but lacks the emotional connection that medieval warriors felt toward theirs. Maintenance was also a personal ritual. Knights and their squires cleaned, polished, and repaired their armor after every engagement. This hands-on care created deep familiarity with every joint and plate. They knew exactly how much damage it could take, which parts needed reinforcement, and how to adjust it for maximum mobility. That understanding created an intimate bond between fighter and armor, a connection modern materials and mass production can't replicate. Ultimately, medieval armor worked so well because it was human-centered. It wasn't just about steel. It was about craftsmanship shaped around the warrior's body and spirit. That fusion of engineering, physical conditioning, and emotional trust made knights far more than soldiers in metal suits. It made them living fortresses, something modern body armor still strives to achieve. Number 5. When technology forgot its roots. As gunpowder weapons reshaped warfare in the late Middle Ages, the once invincible plate armor began to lose its battlefield dominance. Muskets and early rifles could pierce steel at close range, leading armies to abandon the centuries-old craft of personal armor. What followed was an era of light uniforms and minimal protection. Soldiers traded resilience for speed, assuming that armor had no place in a world of gunfire. Yet, centuries later, the same principles that medieval blacksmiths perfected have quietly returned under modern names like ballistic plating, angled protection, and layered composite design. The irony is striking. Modern engineers now rely on the same core ideas that medieval armorers discovered through trial and battle. Curved surfaces to deflect energy, multi-layer systems to absorb shock, and modular construction for flexibility. All these existed long before carbon fiber or Kevlar. When tanks, bomb suits, and advanced exoskeleton prototypes were developed, their creators unknowingly revisited the blueprints of the Middle Ages. The most efficient modern armor systems mimic the same design logic of plate armor: redirect the blow, distribute the impact, and protect vital organs first. After firearms made steel plates obsolete for infantry, technology focused on firepower rather than defense. For centuries, armies accepted vulnerability as part of warfare. Only in the 20th century, during industrial conflicts and urban combat, did the need for protection return. Soldiers once again faced shrapnel, explosions, and close-quarters fighting conditions eerily similar to medieval battlefields. In response, designers reintroduced hard armor plates into military vests. Riot police, bomb squads, and tactical units today wear gear that resembles medieval armor, far more than the soft flak vests of the mid-1900s. The rediscovery of those ancient design lessons shows how advanced medieval technology truly was. Armorers didn't have modern physics or material science, yet they understood how to manipulate force through geometry and metalwork. Their legacy is visible in every armored vehicle, ballistic helmet, and reinforced vest used today. The difference is mostly in materials. Steel has been replaced with ceramic composites, titanium, and advanced polymers. But the concept remains identical. In a way, modern technology forgot its roots and then found them again. The same logic that protected knights in chaotic melee now safeguards soldiers and law enforcement officers in the modern era. What we call innovation today is often a rediscovery of medieval genius that never truly stopped working. It was only set aside until the world caught up. Number 6. If knights fought today. If medieval knights lived in the modern era and had access to today's materials and technology, their armor would not look outdated. It would be a revolution in personal protection. The principles that made their armor so effective centuries ago still apply, but with lighter alloys, advanced composites, and biomechanical design, the result would be something close to an exosuit stronger, faster, and smarter than anything on the battlefield today. The biggest difference would come from materials. Instead of carbon steel, knights would use titanium, graphene, or ceramic composites that are lighter yet stronger than anything forged in the Middle Ages. With these, a full suit of armor could weigh less than 15 kilograms and still resist high-velocity rounds and shrapnel. The curved design of plate armor, originally meant to deflect arrows and sword blows, would now work perfectly against modern bullets by redirecting kinetic energy away from the body. This is the same science behind armored vehicles and bulletproof shields. If adapted properly, a knight's design could offer 360-degree ballistic protection without sacrificing agility. Mobility would also reach a new level with powered exoskeleton systems, already being tested by military engineers worldwide. These systems use electric servos to amplify a soldier's strength, allowing them to carry more weight and move faster for longer periods. When combined with a knight's ergonomic design principles, it would create a seamless balance between movement and defense. Imagine a modern armored knight able to sprint through combat zones with near impenetrable protection while lifting heavy gear or injured allies without exhaustion. Even the helmet design from medieval times had lessons that modern tech could refine. Knights' visors were designed for full facial protection while maintaining visibility and airflow. Replace steel with bullet-resistant glass, add integrated heads-up displays, and you'd have a perfect blend of ancient logic and digital warfare capability. The armor would no longer just protect, it would enhance awareness, strength, and endurance. In many ways, this futuristic soldier already exists in concept. Military research programs, from the US Army's Talos suit to Japan's Power Assist armor, borrow heavily from the knight's philosophy: protect the whole body, maintain full range of motion, and combine human instinct with mechanical support. If knights fought today, their armor wouldn't just work, it would outperform modern body armor entirely. It would prove that the genius of medieval engineering wasn't a relic of history, but the foundation for the future of human defense. The knight's code may have faded, but his armor's legacy is only getting stronger.